Hello again. In this video, I'm going to just briefly touch on the peril of using the double equal sign when you have floating point decimals. This is something I don't want to dwell on. I don't believe it's ever going to come up again in the course. At the same time, it's something that a budding data analyst ought to be aware of. The take-home message is if you have decimals, you're going to want to avoid using the double equal sign. And let's just show the classic example that everyone shows their students. What is 0.3 divided by 0.1? This is not a trick question. It is elementary school mathematics. 0.3 divided by 0.1 is 3. So let's let A be 0.3 divided by 0.1. And let's write the conditional if A equals 3. We display the string 0.3 divided by 0.1 is equal to 3. And otherwise, we'll display the string question mark. Well, we run the code. And it would be a little deflating if we got this string. We do indeed get the question mark. Something has gone wrong under the hood. And what's going wrong under the hood is that everything in R is stored in binary. And that, I mean, not just R, Python, any computer language. That's just how computers work. At the end of the day, everything is zeros and ones. So in the standard decimal base 10 system, 0.3 is very nice. But R cannot store 0.3. Because in binary, it is an infinite decimal. And likewise, 0.1. So it looks like R is storing 0.3, but under the hood, 0.3 is actually a very messy decimal that is only approximately 0.3. And I mean 2.999999999. I'm already regretting this. 99988. I might have missed a 9 or 2, but I mean, for almost all everyday purposes, 0.3 is close enough to the real 0.3 that it doesn't matter. But 0.3 isn't really 0.3, and 0.1 isn't really 0.1. So when we take this thing that isn't quite 0.3 and we divide it by this thing that isn't quite 0.1, 1. We get something that isn't quite 3. So R looks at this and it says, well, A isn't 3. A is 2.999999999999955, and it works. It does what it's supposed to do. It says, well, this is a false statement, so I will not run this code. Instead, I will run this code. We can get around this. This is not a fatal error. There's a function O dot equal that checks whether two numbers are equal up to some tolerance. And we can adjust the tolerance as an argument, but the default tolerance is fine. O dot equal is pretty much designed to resolve issues like this. Up to the tolerance of O dot equal, 3 and 0.3 divided by 0.1 are equal. Incidentally, the dot in O dot equal does not, as it would in Python, suggest that this is some kind of method. It's just what the function is named. At the risk of getting lost a bit in the weeds, notice that I have the O dot equal inside another function. Is true. If I run O equal 3, comma 0.3 divided by 0.1, I get true. These things are equal. If I replace the 3 with a 4, I don't get a false. I get a string. Mean relative difference between these numbers is 0.25. So if I didn't have the is true, and I tried to run this with 4, it would give me an error because the if statement doesn't know what to do with the string mean relative difference 0.25. So what the is true is doing is it's turning any string I get into false. So all equal 4, comma 0.3 divided by 0.1 is a string. A string is not a Boolean. A string is not true. So when I take the function is true and I feed it the string, it turns to false. And the if statement understands true or false.